So what were our key takeaways from this lesson? Well, our main takeaway that we already had kind of established earlier on when we talked about discontinuities is we said that a function has a vertical asymptote if direct substitution gives a non-zero divided by 0 result. That's an automatic thing. If you take the value in and you substitute it in and you get some non-zero divided by 0 result, that tells you there's a vertical asymptote there. We also looked at how we can analyze the difference between an asymptote, and we could also tell that a function has a removable discontinuity if the factor that's in the denominator that's making this function equal where you're trying to divide by 0, but if that factor can be divided out completely from the denominator, meaning that the similar factor is also in the numerator, normally is what that means. But if it divides or cancels out completely, that's going to tell you about the presence of a removable discontinuity. And the last thing we really focused on in this lesson is that we can analyze the one-sided limits of functions to describe this infinite behavior. So when we have vertical asymptotes, the limit may not exist. In fact, the limit does not exist at that particular value. But we can use and we can analyze from the left and the right whether the function is growing unbounded towards positive infinity or towards negative infinity. And that requires just a little bit of analysis of the function at that particular value in order for us to describe that behavior with either positive or negative infinity.